Oh,
You got this.
right. Hi, everyone.
How are you guys doing? I hope everyone's having a wonderful time. Our icebreaker for today is what are your grades and where do you guys live? And as a bonus question, we have if you guys could choose any TV show to live in, what would it be? Isha, what TV show would you like to live in?
I don't know. There's like a lot of cool TV shows, but I also don't want to live in one where I would like die suddenly, like the Hunger Games.
Yeah. I feel like you want like a good balance of a little bit of danger and magic, but also like perfectly safe, you know?
Yeah, I'm feeling that. Maybe like the Harry Potter and like Percy Jackson sort of worlds, because I feel like you could live safely, but there's still some pretty cool things.
Yeah, but wasn't there like a saying in Percy Jackson where like most people die within before they become adults and Camp Half-Blood?
Well, I bet we could ignore that fact in
Um,
our.
yeah. Okay. I Tan News says Vernon Hills and Oddballs and Netflix. I have never heard of those two TV shows. Have you, Isha?
No, I haven't, but they sound really interesting.
They do. If you guys were in Percy Jackson, what like cabin would you be like in terms of your godparent? Who would that godparent be for you guys?
Who would it be for you, Michelle?
Um, I feel like I would love to like dorm with Annabeth. So maybe Athena.
Oh my gosh, good choice. I would probably do Athena too.
Yeah. Okay. Arya says that they would like to be in Harry Potter. And on the similar note, Isha, what's your house in Harry Potter?
I actually don't know. I think I'm a Gryffindor.
Makes sense. That
What
is
are
a
you?
very I am a Slytherin, which is very fun.
Ooh, cool.
Okay. I see there's a lot of Ravenclaws in the chat, and Noah says that they would be the son of Poseidon, which is really, really cool. And that they love lightning thief. I agree. Right now, my brother's in sixth grade, so he's like getting obsessed with the Percy Jackson series. And so he is like now completely obsessed with Percy. And I think he's trying to become Percy. It's like very weird. Anyways,
My brother also had a huge Percy Jackson phase in middle school.
yeah, I think everyone does. He's also going through a Wings of Fire phase, but I went through too. But with Wings of Fire, it's interesting because in Wings of Fire, there aren't any humans, or there are, but like it's mainly about dragons. And so, if you were to live in Wings of Fire, would you live as a human or live as a dragon? Because I would not like to be a human in Wings of Fire. Like, no,
I've not actually read the series, but being a dragon sounds really cool.
definitely.
Why wouldn't you want to be a human?
Nope. I think the dragons eat the humans. I haven't read Wings of Fire in such a long time, but that's what I remember.
Oh my gosh, that sounds really scary. I wouldn't want to be a human in that either.
Uh-huh. Yeah. And okay, I'm seeing a lot of Nightwings and Starflight. So Eric says that they eat scavengers. Yeah, I think that's how the book phrased it. Okay, so Helen says that they're a Ravenclaw. In Percy Jackson, they would be the daughter of Athena, and they would be a Rainwing.
I, I see we also have some Gryffindors, like Jaden says Gryffindor, which is awesome.
You know what else would be kind of fun to live in?
What?
Wouldn't it be fun to like live in Star Wars and like just fly on those ships through outer space?
That would be so cool.
Uh-huh.
One of my personal worries about going in space is like the health effects. So I wonder if like we do live in Star Wars if that would happen.
Yeah. Have you ever seen like the theory where like the twin paradox, where if you have one twin on Earth and one twin go to space, they end up coming back at different ages? So
I
like,
have heard about that one.
yeah, so I wonder how that would work. Eric says that we might encounter black holes, and that would be very, very interesting. Because there's a theory that if you were to get sucked in a black hole, you would actually come out in a white hole in an alternate universe where time runs backwards.
Interesting.
Uh, But in the meantime, I think we should start doing some math. But before that, we do have a wonderful, amazing guest speaker with us. Ying, do you have anything you would like to say?
Hi, Michelle. Nice to meet you. Thank you. Hello, everyone. My name's Ying. I'm one of the Iowa State co-director for Math Kangaroo. I came to know Math Kangaroo because of my eldest son who likes to tackle challenging and fun problems from Math Kangaroo. For my job, I teach college students in the classroom setting. Being a mom passionate about motivating children to love math, I volunteer to teach in the math club at my kids' school. Since my son started to know Math Kangaroo, he found it so fascinating and so cool. So I joined the Math Kangaroo team this year and started to teach kids strategies and techniques in solving math problems. I really enjoy exploring the world of math with these curious young minds, which is all of you here today. I hope you could also join us in this fun journey in the Math Kangaroo world, which could open your mind on problem solving and critical thinking skills. Some background information about Math Kangaroo competition. So for those of you who have participated, you probably know this already, but for those of you who are new to Math Kangaroo, I just want to spread some word of mouth about this. So Math Kangaroo usually opens registration in the fall for the coming year, the March competition. The in-person centers usually close in early January, but we do have some online test centers that are still accepting registrations for this March competition. Should be until the end of February, which is this month. So if you are interested, please visit mathkangaroo.org to register for this year's competition. In addition, not Math Kangaroo not only hosts competition every year, but also offers group and private lessons, webinars, and a lot of online math learning resources. Like today, we are partnering with our great co-hosts, Michelle and Isha, for you to get you introduced to this Math Kangaroo world. So if you are interested, you can visit our website to find more information. Now, let me introduce our co-host from Daily Challenge. So Michelle is a 10th grader who loves math. She has participated in math competitions and last year received an honorable mention in the UMD, University of Maryland math competition. Outside of math, she enjoys playing violin, volleyball, and petting her cat. And our second co-host today is Isha. She placed top 5 in a local math competition and has taught numerous students over her years of experience. She was in the 3rd place National Science Bowl team and represented Washington State at the first Tech Challenge World Championship, both of which she applies to advanced math. In her free time, she loves to program. So let's welcome. Thank you.
Yeah, without further ado, let's start solving questions. So, for the first question, we have fishes. And it says, how many fish will have their heads pointing towards the ring when we straighten the line? And this is very confusing because the line is actually all and loose. And so, even though a fish might be technically pointing towards the ring, it might not actually stay this way when we straighten the line. And so let's be very, very careful about how we approach this problem. Personally, I think the easiest way is just to follow the hook like through this line and just see For how many fish do we touch their mouth first before their tail? So let's just start drawing this line. So for our first fish, we touch the fish's mouth before we touch the fish's tail. And so when we straighten the line, the fish's head is going to be pointed towards the ring. And so let's just circle this fish. And now, if we continue drawing the line, we get to this new pink fish. And for this pink fish, we touch its tail before we touch its mouth. And so when we straighten this line, then the fish's head is actually going to be pointed in the opposite direction of the line. And so this fish is now pointed towards the ring. And continuing this method, for the rest of the fishes, we find that this fish is pointing towards the ring, this fish isn't, this fish isn't, this fish is, this fish is, this fish is, this fish isn't, and this fish is pointed towards the ring. And so counting up all our fishes, we get 6 fishes that are pointing towards the ring, and that gives us an answer of C.
Awesome. I really think like tracing a line is really creative because when I first looked at it, I was kind of just looking at the fish and accounting for the fact that stretching it would turn it backwards, which is definitely much more of a hassle.
Yeah, I think these visualization problems are always a little bit tricky, even though they're not necessarily the hardest mathematically. They're always a little bit difficult to get your mind around.
Definitely. All right, I'm going to go ahead and move on to the second question. And this one, we have someone drawing a picture of a sun, which is pretty cool. So when I first look at this, I'm looking at these longer spikes because I noticed that there's only 6 of them in this diagram. So for me, that's really easy to identify. So there's for the ones that are too high close together, you can just like look at the diagram. It doesn't really seem that there's too high poles close together. If we move on to the there's not 2 high poles like next to these 2 like small poles in this diagram. So I'm just moving on to the second option, and you actually notice that configuration B is right on this left side of the sun. So I think that would be our answer.
Yeah, exactly. So just as Isha said, we can just look at the diagram and compare it with the sun and see what our answer is. Moving on to our next question. A measuring tape is wrapped around a cylinder. What number should be at the place shown by the question mark? And initially, this question is like really, really difficult because we have to calculate, well, we seemingly have to calculate the circumference of the cylinder, and maybe we even have to account for the fact that not only does the tape wrap around the cylinder like in this way, it might also be traveling up the cylinder. But there is actually a slightly better way to approach this problem. And that's because we know that we have a 6 here and a 27 here, and they're placed right on top of each other. And it just by chance, this question mark happens to be placed exactly on top of the 27 as well. And so because how this measuring tape is wrapped around the cylinder stays constant, the distance between the number 27 and the number 6 on the measuring tape should be the same as the distance between the question mark and 27 on the measuring tape. And so because the distance between 27 and 6 is 21, we know the distance between the question mark and 27 is also 21, which gives us an answer of 48C.
Awesome. I got the same thing, and it looks like that's the answer. So nice job. All right, moving on to the next question. We're looking at a weighing machine now, and we need to predict the weight of the white ball. So what I'm first going to do is I'm going to write some equations. So I'm going to say the gray ball plus the black ball is equal to 6. 2 white balls plus a gray ball is equal to 14. And 2 gray balls plus a black ball is equal to 10. So I noticed that the first and the last equation both have just 1 black ball. So what I'm going to do is I'm going to actually subtract those 2 equations. I'm going to do 2g plus b minus g minus b is equal to 10 minus 6. So what you get from this is that the gray ball is actually 4, but that's not our answer because the question's asking for the white ball. So what I'm going to do is I'm going to plug this directly into our second equation, which deals with white and gray balls. So now I'm going to get 2w plus 4 is equal to 14. So 2 white balls is equal to 10, and white is equal to 5. So my answer would be option C.
Exactly. So just a little bit of equation setting, we got our answer of C. And on to our next question, which is Sophie wants to pick 5 different shapes from the boxes. She can only pick one shape from each box. Which shape must she pick from box 4? Now, looking at the shapes, the first thing I realize is that in box 3, there's only one shape. So from box 3, she has to pick the circle. And similarly, I noticed that in box 1, there is only a star and a circle. But because she picked the circle from box 3 and we want to pick 5 different shapes, then she must have picked the star from box 1. And now, similarly, looking at box number 5, because there's a pentagon and a star, and we know she wants us to pick 5 different shapes, and we've already picked a star. In box 5, she must have chose the pentagon. And now, taking a look at box 2, I noticed that there's a triangle in box 2, but in none of my other boxes is there a triangle. So if I want to have 5 different shapes from each of my 5 different boxes, then I know I have to pick the triangle. And since the only place the triangle exists is in box number 2, we have to have picked the triangle from box number 2. And now by process of elimination, because we've already picked the star, triangle, circle, and pentagon, we must have picked the rhombus from box 4. And so our answer is E.
Awesome. And it looks like that's the answer. Oh, great. All right, moving on to our next problem, we have some colliding balls. But in this case, they're moving in opposite directions and they're kind of like consuming each other. So what I'm first going to do is I'm going to start with 2 balls that are closest together. So for me, that's going to be 9 and 3. So obviously 9 is greater than 3, so we're going to have that turn into 12 because 9 plus 3 is 12, and it's going to be moving in the right direction. All right, then you can combine 12 with a 7 ball, so 12 is larger, so that's going to be 12 plus 7 is 19, and you're still going to be moving in the right direction because that's the direction of the largest ball. All right, now I'm going to take the 19 and I'm going to combine it with the 20. So the 20 is actually larger. So I'm going to do 19 plus 20, that's 39, but we're no longer going in the right direction. We're going in the left because the 20 ball is larger. All right, we only have 1 ball left. We have the 39 colliding with the 10, so 39 is larger, so that's going to lead us 49 and still moving in the left direction. So that gets me an answer of C.
Yeah, Isha's exactly right. That's exactly how I would approach the problem too. Just looking at the collection of balls and just going through it step by step or collision by collision. And on to our next problem, problem 14. The koala ate some leaves from 3 branches. Each branch has 20 leaves. The koala ate a few leaves from the first branch and then ate as many leaves from the second branch as were left on the first branch. Then it ate 2 leaves from the third branch. How many leaves in total were left on the 3 branches? Now we can calculate how many leaves are left on each branch, or we can calculate the number of leaves the koala ate in total and then subtract that from our total amount of leaves. For me personally, it's a little bit easier to do just directly count how many leaves the koala ate. So from our first branch, the koala ate some number of leaves. We don't know this exact number, but we know that the koala ate some number. And then for the second branch, the koala ate as many leaves as were left on the first branch. So in total, after these first 2 branches, the koala has eaten exactly 1 branch worth of leaves because she ate a part of the branch on the first branch, and she ate the second part of the leaves on the second branch. And so in total, after the first 2 branches, my koala has eaten 20 leaves because there are 20 leaves on each branch. Then finally, on the third branch, the koala eats two more leaves. So in total, from the first, second, and third branch, my koala has eaten 22 leaves. But remember, the question isn't asking how many leaves has a koala eaten. It's asking how many leaves in total were left on the three branches. And so we have to find the number of total leaves on the branches, which in this case is 3 times 20, which equals 60 leaves, and then subtract it from these 22 leaves to get 28 leaves, which I think is our answer.
Awesome. I kind of did it the other way where I did it the number of leaves that were left. So, but it's actually a really similar approach because for the first two, the number that are eaten is actually equal to the number that are left. And then since uh, the koala ate two leaves from the third branch, you kind of get 18 for the last one. So would the answer be 38 instead of 28?
Yeah, exactly. My bad. A lot of you guys got this in chat, so wonderful job. But 60 minus 22 is not 28, it is 38. So bad job on my part. Subtraction is quite a difficult thing. And so our answer is actually E, not C. Thank you to Isha and thank you to chat for catching my mistake.
Awesome. Subtraction is really hard. All right, moving on to our next question. We actually have some cup flipping. This actually reminds me of one of my favorite songs, like the cup song. But anyways, we have three cups sitting on a kitchen table, and essentially we're just moving them to the end and flipping them over. So the way I would approach this is, well, what is 10 mod 3? So the reason I immediately jumped to this is because we're going 10 moves and we're flipping three cups. So that means for every three moves, all the cups are going to be going from one position to the other. So that means if we start with all of them facing up, after three moves, all of them are going to be facing down. And then after three moves, all of them are going to be facing up again. So then we're left with one more move, which would flip. Two of them would be down, and then one of them would be up. If that makes sense.
Yeah.
So that gets me B.
Exactly. And to kind of iterate this like mod 3 kind of idea, I've written the cups in terms of ups and down, where a cup facing the right direction, so like this cup is up, and a cup facing the wrong direction, in this case, is down. And so you can kind of see exactly what Isha was saying, where after flipping the cup three times, they go from all up to all down. And then after flipping the cups three more times, they go from all down to all up again. So after 10 times, the cups should be here where the four is. So down, down, up, which is exactly what Isha said.
Awesome. Thanks for clarifying that.
Mhm. And on to our next question. Eva has five stickers shown: triangle, circle, star, flower, and apple. She placed them on each of the five squares on the board, placing one on each square so that the star is not on square 5, the apple is not on square 1, and the flower is next to the circle and the triangle. On which square did Eva place the flower? So let's work from like back to front for this question. So our goal is to find which square Eva places the flower. And our first piece of information is that the flower is next to the circle and the square. So that kind of gives us two possibilities. The flower might be here with the circle here and the square here, or the flower may be here with the circle here and this triangle here. My bad, not square. But in both these ways, does it really matter which side the triangle and circle are next to the flower on? Because at the end of the day, we're only trying to figure out where the flower is. We don't really care about the placement of the triangle or the circle. And so what we can do is we can just pretend that this triangle flower circle mess is just one big sticker, where in the center of the sticker, there's a flower sticker. Okay. And now moving on to another piece of information, which is that the apple is on square one. So let's just cross out square one because we know that the apples are not in there. And then we have that this star is not on square five. So now we kind of have four stickers left to deal with. We have the star and the three smaller stickers of circle, flower, and triangle, which we're just going to pretend is one sticker for now. So in reality, we kind of have two stickers, one big, humongous chunk of three stickers and one tiny star sticker. And we're trying to place them into the boxes 2, 3, 4, and 5. But since we only have two stickers, there's only two ways to place it. We can either place the star on the right of the big stickers or on the left on the big stickers. But if we place the star on the right of those three big stickers, well then the star is on box number 5, which is not possible. And so the star must be on the left of the three big stickers, meaning that the three big stickers occupy spots 3, 4, and 5, and so that the flower occupies spot number 4, which is D.
Awesome. I got the exact same thing, and it looks like that's the answer. All right, moving on to our next question. This time we're popping balloons, super fun. And Mia's throwing darts, and she scores 30 points, so we need to see which of the balloons she must hit. So my first intuition is to try to find two possibilities and see which number overlaps between the two. So the first way that you can add to 30, well, let's start from 18 because that's the largest number. So 30 minus 18 is 12. Are there two balloons that add to 12? There is. There is 9 and 3. So our first possibility is having 3, 9, and 18. All right, so I'm going to kind of move down to 14. So 30 minus 14 is 16. And are there two balloons that add to 16? There is. There is 3 and there's 13. So the second possibility is 3, 13, and 14. And between these two possibilities, the only one that's overlapping is 3. That must be our answer.
Yeah, that looks exactly right. I really love your strategy of just starting with the bigger balloons and seeing which of the smaller balloons can fit with it to add up to 30. I actually did this problem in a slightly different way though. So for this problem, instead of looking at the biggest numbers, 18 and 14, I noticed that 30 is divisible by 3. And out of our 5 balloons, 3 of them are also divisible by 3. This 3 balloon, this 9 balloon, and this 18 balloon are all divisible by 3. And what this tells me is that for the balloons that aren't divisible by 3, which are only 13 and 14, they have to be together. Because if it was just 13 on itself and then adding with one of the balloons that are divisible by 3, we're going to get a sum that is not divisible by 3. So this 13 and 14 must be grouped together. And so now we kind of have a 4 balloon situation where we have a 27, 9, and 18. And then from there, I then grouped the balloons 3, 9, 18, and 3 and 27. Yeah. Which
Awesome.
guesses is, yeah.
I really like that approach. I didn't really recognize that those two could be combined to 27. All right.
Moving on to our next question, which is each of the boxes contain either apples or bananas, but not both. The total weight of all the bananas is 3 times the weight of all the apples. Which boxes contain apples? So we don't know the sum of the apple weights or the sum of the banana weights, but we know what the sum of the total apple and banana weights is, because that is just the sum of the weights of all the boxes. And so we get that the sum of the weights of the apples and the bananas is 7 plus 5 plus 6 plus 2 plus 16, which is 12. Let's hope I don't mess up arithmetic again. 12 plus 6 is 18, plus 2 is 20, plus 16 is 36. And so the sum of the total weights of all the apples and bananas is 36. But we also know that the total weight of all the bananas is 3 times the weight of all the apples. And so we know that bananas plus apples is equal to 36, but bananas is equal to 3 times the weight of apples. And just solving this equation, we get that apples is equal to 9 kilograms, and the sum of the banana weights is equal to 27 kilograms. And so now we're tasked with finding which boxes contain apples. We know that the sum of the boxes must be equal to 9. And so we can kind of look at our answer choices and say, hey, A is box 1 and 2. That's up to 12 kilograms, so that's not right. Choice B is 2 and 3, which sums up to 11, which is not right. Choice C is 2 and 4, which sums up to 7 kilograms, which is not right. Choice D is box 3 and 4, which sums up to 8 kilograms, also not correct. But choice E is box 1 and box 4, which sums up to 9 kilograms, and so choice E must be the correct answer. Yeah. I think the trickiest part of this problem is just figuring out that, hey, even though we don't necessarily know the weights of the bananas and the apples, we know the sum of the total weights. And so from that, we can figure out our solution.
Cool. And it looks like E is our answer. So that's great. All right, moving on to our last problem for today. Comparing yet another set of weights, but this time it's more of a scale because we're comparing the weight of these 3 different objects. But I'm still going to, it's similar to the last question that we use scales on. I'm going to be setting up some equations because that helps me take these diagrams and turn them into something that makes more sense. So 2 hexagons is going to be equal to a triangle plus a square. Then we have a triangle plus a hexagon is equal to a hexagon plus 5 squares. And then the last one, we have 3 hexagons is not really equal to 2 triangles. And we need to see what we need to add to that last equation. So something that pops out to me directly is the second one, where we have a hexagon on both sides. So we can just cancel those out. And then we're left with a triangle is equal to 5 squares. All right, so my next step is to kind of jump over to the last equation because we have 2 triangles on one side, which means that on one side we have 10 squares. Let's see what hexagon is in squares. So we can go back to our first equation and we have 2 hexagons plus triangles, but 2 hexagons is equal to a triangle plus a square. So we could do 2 hexagons is equal to 5 squares plus a square by substituting in what we found out in the second equation. So 2 hexagons is equal to 6 squares, and a hexagon is equal to 3 squares. So that means on the left side of our last equation, we have 9 squares. So in order to balance it out, we just need to add 1 square to the left side. So that means that our answer is A.
Yeah. I love the way you just approached that problem with thinking about it in terms of squares. I think another way to view this problem is to, instead of using variables for all 3 of our shapes, we can directly just let the weight of a square be 1. Because scales like these, they don't really tell us how much a shape weighs. They tell us more of how much shapes weigh in comparison. So for example, if I took my cat and my dog and I put them on a scale, my dog would be how much my cat and dog weigh respectively, just that the dog weighs more than the cat. So because of this, we can just pretend for one tiny moment, even though it might not be true, that the weight of the square is equal to 1. And I chose 1 because 1 is just a nice number. I like working with the number 1 because it helps me avoid arithmetic mistakes. And then, exactly like Isha noticed, with the second scale, 5 squares is equal to 1 triangle. And so the weight of the triangle must be 5. And finally, we get that 2 hexagons is equal to the weight of the triangle plus the weight of the square, and so that the hexagon must weigh 3. And from there, we get that this amount of weight on this side is 9, the amount of weight on this side is 10. And so to make up for this one piece of weight missing, we just need to add 1 square, which is exactly what Yisha got.
I love all the different types of questions in this competition. Like there's so many different varieties and there's a lot of cool ways to approach it. I really love these.
Uh-huh. I think, yeah, there's just so many. My favorite part of math is just the fact that there's so many different ways to do so many different problems. And it's always so interesting to hear how other people approach problems. But unfortunately, that was our last question. Thank you guys for joining us for today. We really had a lot of fun solving these problems with you guys.
Definitely.
Feel
Well,
free to feel free to stay around if you guys have any questions and just go ahead and pop them in chat. But otherwise, bye.
bye everyone. Thanks for coming. Michelle, what do you think was your favorite question that we did today?
Okay. I think the fish question was probably the most unique in the sense that I haven't ever seen it before. Hold on, let me find it. It's the very first question. So it's like right here. Yeah. What about you? What was your favorite question?
I really like the fish question too, but I think another like cool one was the one that we did like 2 questions ago, like the apples and bananas. I feel like it's taking like the like multiples and like putting it in a new way. So I really like that question.
Definitely. Do you have a least favorite question?
Not really. All these questions were so cool and interesting.
Yeah, they definitely were. But my least favorite question has to be the one that I made the silly arithmetic mistake on. Nothing to do with the question writing, everything to do with me. Thank you guys for catching it. So Luca asks, have we competed in the AMC 8, 10, or 12? So I'm in 10th grade, so I've done the 8 and 10, but I'll be doing the 12 next year. Wish me luck. Isha, what about you?
Yeah, same as you. I'm also in 10th grade.
Okay, he said that they really like the question about shape picking. I
Oh,
think
those ones were so cool, like the scales and like needing to figure out like what the weights were relative to each other. That was really cool.
definitely. I think, yeah, they can get really messy though sometimes, which is why I think it's always helpful to have equations with variables in it, because I think it's just a lot to visualize.
Hmm. I see someone said in chat that you didn't really like the banana and apple question.
I think
Mm.
that's Roman says that they that we missed a couple of questions. So we unfortunately don't have time to do all the questions. But if there's a question you really want to see done, go ahead and pop that in chat and we'll solve it.
I also see that Luca did try taking the AMC 8. I kind of just wanted to say that like for me the AMCs are a way to like look at like how I'm personally improving. So I wouldn't look at your score and say that oh that's like bad or good because all scores are good and the fact that you're doing this in 4th grade is really impressive. I would look at it as a way of seeing where you could improve and see where you can work on because all these questions are really interesting and cool.
Uh-huh, definitely. And I think that it's very not so good to think of yourself badly because of an AMC score. Especially at AMC 8, I feel like in AMC, when you're like in elementary school or in middle school, it's really just important to explore math and not stress too much about the scores. especially because a lot of those AMC 8 questions are really tough.
I definitely agree.
Like, I swear the questions have gotten harder every single year because every single year I feel prepared and then I take the test and I'm like, what the heck just happened?
I definitely feel like the same way after taking the test.
Yeah. So someone asked, when did we start taking the AMC 8 and the AMC 10? So I took my first AMC 8 in sixth grade, um, just because all my friends were taking it. I didn't have any math like practice before that, so I kind of went in blind. And yeah, but after that, I really started to like math more, and so I continued in seventh and eighth. And then, of course, I took the 10th when I was in ninth grade. What about you, Isha?
I also started AMCA in sixth grade, and I've just been really liking math since I was in elementary school. So it was kind of just like the next step for me to see if I could try challenging myself. So that's why I did middle school, and then I also started AMC 10 in ninth grade.
Uh-huh. A little bit nervous about 12 the next year.
Yeah, me too. But we're both gonna do great.
Yeah. Okay. So I also see a question about, oh yeah, of course, you guys are free to leave. We're just here to say if you guys want to talk with us or have any extra questions. Yeah, what is AMC? So AMC stands for America's Mathematical Competition or something along the lines of that. Um, it's it's probably the most popular competition, and it is also the competition that ends up choosing like national the national USA team. And so I would totally recommend you guys checking it out.
Yeah. Okay. There's like another question. Which math competition is your favorite? I would say I really like both AMC and Math Kangaroo just because of like the different unique questions that we get on the test. But honestly, I just enjoy math competitions in general, so can't really choose.
Yeah. Um, I've never participated in Math Kangaroo, so I can't say on that. But my favorite competitions are always ones where I get to work with my friends. Those are always the best. Like just being able to, I don't know, just share ideas. It's awesome. So I saw a question about algebra and how to do algebra in specific. Algebra is my favorite topic in math, so I love this question. Um, I think algebra, it's very, it's just important to keep your variables neat and like just be really aware of what you're trying to find and to be really aware of like the different algebraic manipulations you can make. And someone asked, do you like spelling? And I hate spelling. Like it's embarrassing how bad I am at spelling. Like once I literally taught a class and spelled speed like this and didn't notice until like I was halfway through. It was just not a vibe.
All right, I see someone's asking where to find the recording for this. So I'm pretty sure that you can find this on our YouTube channel, which is like Daily Challenge with Po-Shen. And I'm not sure about this my second option, but they probably might email out the recording as well. But you'll be able to find it.
Oh, Lucas says that they're learning algebra this spring/summer, so that's awesome. Um, And Dina asked if there's algebra and Math Kangaroo. And absolutely, we saw a lot of algebra in the past few problems. In fact, Isha like did an amazing job demonstrating how to set up variables in equations. And yeah, and for an example of an algebra question, algebra is just well, algebra is really broad, but I think of algebra as any time we use variables. And so a variable is just a way we represent a number. So algebra might be something like x squared is equal to 9, and then solving x, which must equal -3 or +3. Olivia says that there are two series branching off from the Percy Jackson series. Isha, have you read those two branching out series?
I have. I think you're talking about like the Olympus series where like they meet the other camp, right? And then Magnus Chase.
Yeah, that makes sense. There's also the Kane Chronicles, which slightly unpopular opinion is better than the Percy Jackson series. So if you guys haven't read it, please check it out.
I share your opinion on that one. I love the King Chronicles series.
Yes. Oh, so Olivia was referencing the heroes of Olympus and the trials of Apollo. That's really, really cool. Okay, Luca asks if we like counting square roots to the nearest hundred. I don't know what you mean, but anything with the word counting and square roots and nearest hundred makes me a little bit nervous, so I'm gonna say no.
I also see a question. Have you read Harry Potter? I've read Harry Potter, and it was like a huge like phase generally in my grade when I was in middle school. So I think everyone at my school's probably read it.
I think so too. I feel like Harry Potter is something every single middle schooler or elementary schooler has read at some point in their life. So Adina asked, did we cancel anything in algebra? And I assume when you say canceling, you mean something in the case where we have like x plus y is equal to y plus 3, and then being able to cancel those y's and just getting x equals 3. And yeah, we definitely did cancel stuff in this live solve with the weighing question. And Isha, do you want to pull that one up?
Yeah, sure. So you can't always cancel anything, but particularly in this question, we had a hexagon on both sides, so we could cancel it out. We also talk about like in like some of the live classes about like telescoping sum, which is like completely cancellation except for these two terms. So there's definitely a lot of cancellation involved um in algebra.
Yeah. And if you guys want to learn algebra and learn these telescoping skills, there actually is a class offered by Daily Challenge that teaches a lot of cool algebra tricks if you guys would like to check it out.
Yeah, there's actually we offer two algebra courses. One of them is kind of like on the basics of algebra, and then one of them goes into like the really nitty-gritties, and both of them are super, super cool.
Definitely. And there's even a lot of algebra in the non-algebra classes too. For example, in the pre-algebra class that I'm teaching right now, we're learning about telescoping sums, which is just this really cool idea of canceling a bunch of numbers over and over and over and over again and adding infinite amount of numbers. So it's super duper cool, and you guys should totally check it out. Isha, do you want to show what you have on your screen right now?
Yeah, so this is the live website, and you'll notice that these are like the six different courses that we offer here. And I think that we're gonna start another session around March. So if you're interested, you should totally sign up.
Uh-huh. Yeah. You guys have any other question, any other thoughts or comments that you guys would like to share? If not, then we're very glad to have you here. Definitely a very, very wonderful time talking to you guys and answering questions.
Thanks everyone so much for coming. We really enjoyed it.
Bye. Patrick asked if we've read Dogman. I've seen my brother read it, but I think by the time I was done with middle school, elementary school, like where I would be reading, like where I was reading